All right, so this short video is to help you understand the differences between ionic. In order to understand a chemical bond, we need to know what a bond is. And a bond is simply just a force that is holding groups of atoms together and will make them function as a unit. So this is how atoms are changed into molecules, where we have more than one atom that's bonded together. The bond energy, which you may hear referred to at times, is the energy that is required to break a chemical bond. So in order to have a chemical reaction occur, we have to break bonds between atoms and then rearrange those atoms and have them form new bonds to make new molecules. The first type of chemical bond we're going to talk about is ionic bonding. Now, ionic compounds will break into ions in water. So we can take something like sodium chloride, commonly known as table salt, we can put it in water, stir it up, and those ions will actually break apart into solution and will conduct electricity. An ionic compound results specifically when a metal reacts with a nonmetal. And because the metals want to lose electrons and nonmetals want to gain more electrons, we have a transfer of electrons from the metal to the nonmetal. When that happens, that is removing a negative charge from the metal, which leaves it positively charged, giving that negative charge electron to the nonmetal, which then makes it negatively charged. So we have these positive ions and negative ions, and because of that charge difference, they're attracted to each other. And that's what makes an ionic compound. On the other hand, covalent bonds are formed when we have two atoms that both want more electrons. So remember, metals are losing electrons, nonmetals are gaining electrons. So if we have two nonmetals, both of them want more electrons. If we get two hydrogen atoms close enough together, they each, because they want to look like the noble gas on its row, helium, they would like to have a total of 2 electrons. And because of that, if hydrogen gets close enough to another hydrogen, they decide to share their electrons together. That way, instead of each one just having one, if they come together, they'll both get to share 2. And then both hydrogens will feel like it has 2, and that makes it far more stable. So a covalent bond results when electrons are shared by nuclei. So in size. So if we look at the first column or group on the periodic table, those are all metals with the exception of hydrogen, and they always form a +1 cation. Okay, cation just means positively charged ion. Anion just means negatively charged ion. So because group 1 metals will lose an electron, that leaves it with a +1 charge. Group 2 metals, or the second column, beryllium, magnesium, calcium, and so on, they all want to lose 2 electrons, and so they will form a +2 or 2+ cation. Aluminum wants to lose 3 electrons, so it becomes +3. And then all of our halogens, that's the second to last column, fluorine, chlorine, bromine, iodine, astatine, they all want to gain 1 more electron so that it will have a very stable electron configuration, and it will have the same number of electrons that its neighboring noble gas has, which makes it very, very stable. And so because it wants to gain that negatively charged electron, it becomes negatively charged itself, and it will have a -1 charge. Now the next column in, the oxygen column, oxygen, sulfur, selenium, tellurium, and polonium, all want to lose, they all want to gain 2 electrons. So that will make them a -2 anion. So again, all atoms want to have the same number of electrons that a noble gas has, and that's because noble gases have very stable electron configurations. Atoms in stable compounds usually will have that noble gas electron configuration. So metals will lose electrons to reach noble gas configuration. Nonmetals will gain electrons to reach that same configuration. And because we can predict what those charges on the ions will be, we can also figure out what the ratios of each of these ions would be in an ionic compound. Okay, so chemical compounds are always electrically neutral, meaning there's no overall charge. So that means the charges have to balance in ionic compounds as well. So if we were to make a compound like lithium chloride, if we look for lithium in this table, we see that lithium has a +1 charge. If we look for chloride, Cl, we see over in group 7, the chlorine has a -1 charge. So if lithium is +1 and chlorine is -1, we can put the two of them together in a 1-to-1 ratio and it will balance. We only need one lithium and one chlorine because the +1 and the -1 will add up to 0. But if we were going to make a compound like lithium oxide, LiO, lithium again still has the +1 charge. However, the oxygen is a -2 charge. So in order to add them up and get 0, we would need one oxygen, because that one oxygen has 2 minuses, and we would need 2 lithiums because we need to have 2 pluses to balance the -2 from the oxygen. If we look at actual structures of ionic compounds, we see that the ions are packed together really tight, and that's so that the negatives and the positives are attracting each other, okay? You'll never see two positive ions right next to each other. You'll see the positive and the negative ions alternating, and that's because of what we call electrostatic attraction. Electrostatic attraction is any kind of attraction that's dependent on the charges on something. So just like we know that protons and electrons are kind of attracted to each other, cations and anions are also attracted to each other. And so because they have that alternating structure and they attract each other really tightly, we get these really amazing crystal structures. So any kind of crystal structures is typically typical of an ionic compound. These are just two ways we represent that graphically. All right, and finally, this is a brief multiple bonds, okay? And this goes along with your handout. So when we write Lewis dot structures, we only include the valence electrons, and that is the most important requirement so that the atoms we're looking at will achieve noble gas electron configuration. So this helps us actually predict what covalent bonds look like. So since we're only dealing with nonmetals, they all want to gain more electrons, and in order to do that, they're going to have to share with other nonmetals. And we have two rules, the octet rule and the duet rule. So hydrogen and helium both want to have 2 electrons, so that's the duet rule. Everything else on the periodic table wants to have a valence shell with 8 electrons. Valence just means the outside most energy level. So if we look at something like potassium, potassium is actually a metal. It wants to lose 1 electron, so it will have the same number of electrons as argon. So that's why it becomes a +1 charge. Bromine, a nonmetal, would like to gain an electron, and that's so that it can look like its noble gas right next door, krypton. That's why it becomes a -1 charge. If we look at hydrogen, each hydrogen wants to gain 1 more so it can fulfill that duet rule. In order to do that, they're going to share their electrons together, so that way each atom feels like it has 2. So bonding pairs are what we call electrons that are shared between 2 atoms. Now, if there's an atom that does not have shared pairs of electrons, they're by themselves, we call those lone pairs. So those are electrons that are not involved in bonding and not shared. For example, fluorine has 7 valence electrons. That means 7 electrons in its outside energy level. An F2 2 molecule is where 2 fluorines come together and share 1 electron with the other one. Okay, so each fluorine by itself has 3 pairs of lone paired electrons or unshared pairs. They're only sharing 1 pair of electrons, so there's 1 bonding pair or a single bond. So how do we figure out how many valence electrons we have total, or how many dots we can write in a Lewis dot structure? Well, first we look at something like water. Very simple, basic example that we use a lot. Each hydrogen has 1 valence electron. Oxygen has 6. So if I have 2 hydrogens and 1 oxygen, that means I'm only going to be able to have a total of 8 valence electrons. And in order to get this Lewis dot structure of water, we see that the oxygen maintains 2 lone pairs that are not involved in bonding, but there is a single bond between each hydrogen and the oxygen. Oxygen in the middle feels like it has 8 electrons. Each hydrogen feels like it has 2 electrons, but keep in mind there's only still a total of 8 electrons there, not 12. So a single bond occurs anytime we have a covalent bond with 1 pair of electrons being shared. A double bond is where we have 2 pairs or 4 electrons that are being shared, and a triple bond happens when we have 6 electrons being